Mhm.
কি বুঝাবো তাহলে?
Tell me how the application of limits is applied to this derivative. So what is the main problem here? What did they ask you to find you?
Okay, so they basically asked us to find if you have they give you an equation for the cost
Mm-hmm.
for making a certain amount of radiators from 8 to if you make from 8 to 30 radiators, then an equation for cost for how much they will cost is given. An equation for revenue is also given. They ask us if you increase the amount of radiators made per day from 10 to 11, then about how much extra will it cost to produce one more radiator a day, and what is your estimated increase in revenue for selling 11 radiators per day?
Mm-hmm. So why would you use derivative here?
Well, because to find how much, one easy way to do it is if you want to find how much more it'll cost to make one more radiator a day, if you take the derivative of the cost um, for every radiator, then you can figure out how much it costs to make one radiator.
Right, but what is that cost called in finance?
The marginal cost.
Yeah, you have to use terminologies, right?
Mm-hmm.
You have to use the right terms for the right discipline.
Mm-hmm.
Okay, so when you take a cost and then you differentiate it,
Mm-hmm.
then you get a marginal cost.
Yes.
Why do you get a marginal cost?
Because a marginal cost is basically the increase of it's basically, the definition is exactly a cost added by producing one additional unit of a product or service.
Right, so what's happening here when you're taking differentiation?
When you're taking the derivative here, you're getting the cost per unit, which per radiator specifically.
Right, which in this case the radiator is what kind of variable?
It's independent variable.
Is the independent variable. So every unit change of the independent variable, you're getting
a change in the dependent variable,
which is the
marginal cost.
The marginal cost, which is the cost.
Yes.
But together it's the marginal cost.
Mm-hmm.
Now that allows you to use differentiation.
Yes.
Right? But now the question is, where in this differentiation are we actually using the concept of limits?
Well, differentiation itself is like limits.
Right.
Where when you take the limit of something specifically, the equation of limit being m, using m as the slope, m is equal to f of x plus h minus f of x over h, and we take the limiting value of that as h approaches 0. In this case, h is the, if you have a point at, say, x1, y1 or something,
Mm-hmm.
and h would just be the distance from that point you have to any other point on some graph.
Okay.
So as we take h approaches 0, it's basically saying as both points come together really close.
Right.
And hence we're limiting that.
Yeah.
Which is how limits work. Now when we take the derivative of something, when we take the derivative of an equation, we receive another equation. This equation is basically just an equation to find the limit at every point.
Mm-hmm.
Where in the equation, the dependent
finding the limit of every point, or finding the limiting value of every point?
Both.
Okay.
What's the difference?
Well, there's a subtle difference, I think, conceptually, but that's fine. Just carry on. So you try to apply the concept of radiators, the cost, the marginal cost in all of this h and x and all that you said.
Yes. So, well, first of all, what's it called? When I say it gives you an equation, right?
Mm-hmm.
In this equation, the dependent variable would be m, the slope, the same slope you would have for a limit. But the only difference is when you take a limit,
Mm-hmm.
when you take a limit and, well, actually, no, it's the same thing, I think, actually.
Okay, that's fine.
No.
Just keep explaining.
Yeah, no. I was just thinking for a second, because if you put a value into the equation for a limit, then you get an output value, which would be the value of the limit itself.
Right.
And when you take a derivative, you basically get an equation where if you put the value of something, you receive the value of the limit.
Mm-hmm.
So,
but ultimately, you are doing that.
Yeah, ultimately it's the same equation.
Yeah. Okay.
It's just the limiting one it's more complex, but it's more universal.
Okay. So you haven't still used the terms radiators, cost, marginal cost.
Okay. So when we take the derivative of the cost, right?
Yeah.
What we're getting, and we're taking the derivative of the cost per every radiator.
Yeah.
So what we're getting is the cost per radiator.
Yes. Which one is your H and which one is your X?
H and X.
Yeah.
Well, the thing is, once we take the derivative of something, we've already taken the H.
Yes.
Which is one of the main differences from the limit. The H is already technically approached 0,
mm-hmm.
which is the whole constant once we've taken the derivative.
Mm-hmm.
Which is the proof of a derivative to begin with. And
yes, but what is an H in this case?
In this case, well, the H would, if we were to use a limit, then the H would just be any one point.
The question is,
well, the H would be the H could be in radiators.
That is the answer. So the H is basically the number of radiators, right? So that thing is going to approach
0,
right, and then leave you with the definition of. Think about it. If H approaches 0, it actually leaves you with the fundamental definition of a slope.
Yes.
Which is what?
Derivative?
No. Tell me the foundational definition, the fundamental definition of a slope.
The change in the dependent variable with respect to the dependent variable.
That's not the complete definition. You miss the complete definition, you will always miss to solve a problem right away.
What? For every unit change in something?
That is the fundamental concept. If you do not say for every unit change, that does not complete the definition of slope.
For every unit change of the dependent variable.
For every unit change in
the independent variable.
The independent variable, the change in the dependent variable is the amount of slope.
Mm-hmm.
If you don't say that, you never. So the way you reach that true limit is ultimately H tends to become 0. You're approximating two different points where it's so close that the rate of the change that was happening with H is now just on top of the independent variable. And then you're looking at what the dependent variable changed at that point, and that's basically your slope. And you've already taken the concept of limit, applied it into derivatives. Now for every unit of change in cost is your marginal cost. So you can apply derivatives in figuring out marginal cost. That's the definition. So you could say it in short, in summary this way. Okay. So then we're going to move into the next concept, which is genetics.